audible, I think. One of the participants can remind me.
Yes,
Yes,
sir.
sir.
It is visible.
Visible, sir.
Yeah. So logistic regression, we are discussing the topic. It is a supervised learning model. When we are discussing the machine learning model, yeah, machine learning models are, we know that these are divided into supervised, unsupervised learning models. Today we are going to touch both. Now, so in supervised learning itself, we have regression models and classification models. Regression models and classification models. So linear regression is purely a regression model. Linear regression is purely a regression model, and logistic regression this one is purely classification model. Linear regression is purely can do regression, and logistic regression can do purely classification. Remaining all like KNN, K nearest neighbors, or decision tree, or support vector machine. These models like Bayesian learning, these models can do both regression as well as classification. As we seen, decision tree can do regression and classification. SVM can do both regression and classification. And today we'll see K nearest neighbors. This can do both, can handle regression data and classification data. So here today we are going to see logistic regression, how it handles the classification data, and as well as K nearest neighbors, and one of the unsupervised learning, that is K means clustering. Unsupervised learning and clustering, K means clustering. These three topics we'll trying to cover. So logistic regression is a classification model. It can do only binary classification. Actually, this logistic regression is a parametric method approach. Parametric method, which means we need to provide an equation. Finally, when we have taken a data like some features and rows, so when we have a data set, target variable is there, features are there. So for that data, we need to provide the solution is an equation. The solution is an equation, the best fit equation we need to provide in logistic regression. But in decision tree, what we did, we built a tree formatted thing. For a given data set, we build a tree. But here in logistic regression, we should form an equation. In linear regression also, we should form an equation. These are called parametric methods. Okay, we need to form an equation, and unknown like y is equal to mx plus c is the basic equation will take and find out the what is a suitable m value and what is a suitable c value. These are called, means which methods are providing a equation, a best fit equation for the given data. That is, those are called parametric methods. So in that, logistic regression is one of the method, and linear regression is also parametric method. SVM is also parametric method. In SVM also we need to provide one equation, best fit equation. But K nearest neighbors and decision tree, these two are non-parametric methods. So means the solution at the end for the given data set, at the end the solution is not a equation. The solution is either a tree in decision tree or a best k value for the K nearest neighbors. So again, come to the logistic regression. It is a classification model. When the target variable, means when the y values, we can find x and y values or features and target variable in our data set. When we have a data set, that is our first job. First job is to find out the target variable, what we can do with that data. What we can do with that data, that we should identify. If the target variable has a continuous values, if the target variable has the continuous values, like the values are repeated over minus infinity to plus infinity, these are called continuous values. In that case, we can do regression. So if the target variable values are categorical values, like repeated over 2 or 3 values, or some values like yes, no, good, bad, 1, 0, small, medium, average. So like that, A to Z, 26, 0 to 9 digit classification. Here, the values, target variable values are repeated over some numbers. So then it is called categorical value. So in that case, we can apply classification. And don't be confused here. Regression is the name, but we are not doing regression here. Regression means just equation we are going to find out that equation will be the best fit. In linear regression, as we can see here, linear regression, we are going to find a, a linear line, a straight line or equation that will fit the given data, that will satisfy the given data, that will uh, almost pass through the each and every data point by maintaining less error, by maintaining less error. That is the intention of linear regression. Same way we are providing logistic regression, means here also we are forming same y is equal to mx plus c equation. Otherwise y is equal to w naught plus w1 x1 plus w2 x2. These type of equations we are going to form for the finally. Understood? So linear regression means directly we are going to take this equation, but in the case of logistic regression, the output values are repeated over categorical values like 0 or 1, yes or no. Anyway, we are converting them into categorical values. So output values are categorical values, but when we take this equation, we'll get the y values are continuous values. Understood? Here in logistic regression, y values are categorical values. If we follow the parametric method approach, like y is equal to w0 plus w1 x1 plus w2 x2 plus w3 x3, then it will give us the y values or continuous values. Here w0, w1, w2, w3 and so on are unknown variables. Unknown variables. That is our job to identify the best w values, and x1, x2, x3 and so on are the given features. Y is the target variable. So this is the equation will form, and if you are directly using, the y values are continuous values. Here the y values are continuous values. But for classification data, there the y values are like 1 0 1 0 like that, categorical values. Okay. To convert these continuous values to categorical values, we need to use any activation function. We need to use any activation function. So in logistic regression, we are going to use one activation function, or we can say that is a converter. Converter will convert the continuous data to categorical data. So whatever the activation function we are using, based on that the result will be there. So what are the applications? The logistic regression can do spam detection, diabetic prediction, cancer detection. Everything is classified. All applications are comes under classification. As I said, logistic regression is required a converter to convert continuous values to categorical values. Means minus infinity to plus infinity values. These are continuous values. We need to convert them into 0 to 1, in between 0 to 1. This is what for that we are using an activation function. Here in logistic regression, the activation function is sigmoid function. The sigmoid function is 1 by 1 plus e power minus z. So how we can get the z value? Z value we can get directly from the parametric method. That is, z is equal to, here I have written w beta naught plus beta 1 x1 plus beta 2 x2 and so on, beta n xn. Otherwise we can write this equation as w naught plus w1 x1 plus w2 x2 and so on it will go. Here beta or w or any variables are just unknown variables. That is our target to identify. That is the target. What w values we need to identify. To map the continuous values to categorical values, we are taking the help of converter or activation function. In logistic regression, the activation function is sigmoid function. Understood? So here the sigmoid function 1 by 1 plus e power minus z will gives the values in between 0 to 1. Here sigmoid function equation is there. Whatever the input you can give here, x-axis, whatever the input you can give, the output values are in between only 0 to 1. 0 to 1. So we can consider above 0.5, greater than 0.5, or we can treat as class 1. Less than 0.5 we can treat as class 0. This is a basic functionality of sigmoid equation. So whatever the values, minus infinity to plus infinity, either it is minus 10 or plus 20 or minus 100, 2000, like that, any value it will be compressed in between 0 to 1, so that we can easily classify. For example, if it is a linear regression itself instead of logistic regression, so this will be the direct value. No need to convert, because in linear regression, the y values are continuous values. So our equation also gives continuous values. So no need to convert. But in classification, the output values, the target values are categorical values, but the parametric method equation will give the continuous values.
జాయిన్ అయిన తర్వాత నాకు యాక్సిడెంట్ అయింది. ఇక్కడ యాక్సిడెంట్ అయిన తర్వాత ఏంటంటే ఎన్బిఏ నాకు వర్క్ జరుగుతుంది. అప్పుడు మా కమిటీలో ఉన్న వాళ్ళు ప్యానల్ మెంబర్స్ ఏమన్నారంటే, మీరు తాగండి, కూర్చోండి, మేమే వెళ్ళి కనుక్కుంటాం చెప్పారు. వర్క్ ఏమైనా ఉంటే మీకు ఇస్తాము, మెయిల్ చేయడం చేసేయండి సార్ అన్నారు. సరే అని శ్రీలక్ష్మి మేడం చాలా. సో ఇంకా అట్లా మా హెచ్ఓడి ఏమన్నాడంటే, లేదు మీరు వెళ్ళాల్సిందే అంటాడు కిషోర్ సార్, సుధీర్ సార్ అక్కడ ప్యానల్ మెంబర్. అయితే వాళ్ళకి కూడా ఫోన్ చేసి చెప్పా, సరే అన్నాడు. ఇతను వెళ్ళాలంటాడు, మీ ప్రాబ్లం ఏంటి సార్ అని ఫోన్ మీదనే చెప్పేసి అంతే. ఇప్పుడు మీకు కావాల్సింది ఏంటి, ఇప్పుడు వెళ్ళామంటే ఇప్పుడైనా నేను వెళ్ళిపోతాను, ప్రాబ్లం ఏం లేదు, వాళ్ళు వచ్చి నాకు చెప్తే నేను వెళ్ళిపోతాను.
ఓకే. So here sigmoid function we are using as a converter to convert the linear continuous values to categorical values. That is the main intention of using sigmoid. Otherwise, directly if it is a regression problem, same this equation we can use as a directly the values we can take to the target variable and we can calculate the error. But here this will give the continuous values. Our output is in categorical values. So that for that reason we are using a link function. In that link function we are substituting the z value, and this will be the our y predicted value, also called a link function. If it is a linear regression, the directly yp is equal to w naught plus w1 x1 plus w2 x2. If it is logistic regression, first we are calculating z, that is equal to w naught plus w1 x1 plus w2 x2 and so on. So this is not a y predicted value. The y predicted we can calculate as 1 by 1 plus e power minus z. Now this will convert. Here this equation will give us continuous values that we are substituting here, that will give the categorical values, that will be converted to the categorical values for the classification purpose. So except that everything is same. That's why I've said both are parametric methods. Linear regression and logistic regression, both are parametric method and follows an equation and find the unknown variables. Here, this is after calculating the y predicted value. Now how we can calculate the error? Here, first we'll calculate the y predicted values with the help of 1 by 1 plus e power minus z. We know that z is equal to w naught plus w1 x1 plus w2 x2 and so on. Here x1 x2 refers to the number of features we have. X1 x2 refers to the number of features we have in this data set. Number of hours studied, number of hours slept, and the target variable is pass, whether he will be passed the exam or not. So here we can take these two are x1 and x2. So based on that, we can form an equation. This is an x1 and this is an x2 and this one is the bias. We can add x1, x0 also. That is always 1. This is the equation we can form for this. Now that z values will calculate, that will be substituted in sigmoid equation to get the y predicted values. So after getting the y predicted values, here we have the target values and here we got the y predicted values. Now how we can calculate the error? How we can calculate the error? So in this logistic regression, we are going to calculate the error. Error is equal to minus of y into y means the target variable log of y predicted value minus 1 minus y into log of 1 minus y predicted. It is like true or false. That's why we say it is a binary classification. Here, if you are tossing a coin, if you are tossing a coin, head and tail, there are two possibilities only. Either it may be head or it may be uh, tail. If head is not going to happen now, then tail is the chance of tail to be happen is high. So that's why we divide it like this. If this is the head and this one will be the tail part. Okay, so you can observe here if y value is 1, in this case if y value is 1, this part will be calculated. If y value is 1, this part will not be calculated. That's why 1 minus 1 will become 0. For example, if y value is 0, this part will become 0. 0 into something will be 0 and 1 minus y is equal to 1 minus 0. That's why this is the equation we are using to calculate the error on the trained data. So first we are going to form an equation because it is a parametric method, and we'll find out the intermediate variable z. That z value is substituted in sigmoid equation to get the y predicted value. After getting the y predicted values, we'll calculate the error. Okay, this is the error is called log error or categorical cross entropy error. This is also called cross entropy error or log error. We can find means small differences, it will show very large small differences because our y values are repeated over two values like 1 0 1 0 1 0. So if you are doing a mean square error or mean absolute error, then 1 minus 1 minus 0 will show very small error. It will show the error very small. But if you are using log error, that log value will give us very big. Though mean square error is low, but log will expand the error. It will show magnified error. That's why it is a categorical cross entropy error, or we can say log error for logistic regression we are calculating. Now we'll see problem, this problem, how to solve by using linear regression. This is a target variable. We are treating that as y, and this is a x1, x2. So with that, we formed an equation. Here beta is, otherwise we can also use w also. W naught plus w1 x1 plus w2 x2 is equal to z. This is the way first we'll calculate. Here, how we can find out the w0, w1, w2 values. There is no proper method. Initially, we are going to select random w values. Randomly we can say to select the w values, that is our wish. But the next iteration onwards we can use the any optimizer function like a gradient descent optimizer function or any optimizer we can use to find out the w values. But initially we are assigning w values are 1 1 1. So here w0 is 1 and w1 is 1 and w2 is 1. When we substitute this w0 w1 w2 in this, w beta naught is 1, w done 1 is 1, beta 2 is 1, and x1 is 4.85 and x2 is 9.63. Here if we substitute all these, and we'll get the z value as 15.48. Same way if we substitute 8.62 and 3.23 in x1 x2 place, we'll get 12.85 and 14.66, 14.16.55. These are all z values, not the w, not the y predicted value. These are all z value, just a intermediate values. As I said, when we substitute, when we are using this equation, and if we substitute the values, it will give always the continuous values like this. These are continuous values. To convert these continuous values to categorical values, we are taking the help of sigmoid equation, that is 1 by 1 plus e power minus z. In that way, we'll find out the, this is here, y predicted value. In that way, we can find out the y predicted value. But if you are doing linear regression, if you are doing linear regression, directly a regression problem, no need to convert these continuous values to categorical values. That's point we need to remember. Now here, after initially I took w0, w1, w2 values are 1, 1, 1, and I calculated the z value. Now the z values are calculated through by substituting into sigmoid equation. We got sigmoid values. This is treated as y predicted value. Y predicted value. Here we have y value, and here we got the y predicted value. Here we can see so why we need to calculate the log error. Here we can easily observe. We got y predicted value, we have y values, and if you do any mean absolute error or mean square error, what is going to happen? 1 minus 0.999. It will be a very less error, and 0 minus 0.999 whole square, it will be also very less error. 1 minus 0.0999 whole 6. And if you are calculating any squared error, y minus y predicted whole square, it will not show the big differences. It will not show the big differences. Here look at, actual value is 1 and y predicted value is almost 1. So what will be the log error and what will be the mean square error? This is the mean square error. This is the log error equation. So if we substitute again for second instance, y value is 0 and y predicted value is almost. This is almost 1. So almost the difference is 1 only. Like if it is 0 and it is almost 1. So 0 minus 1 whole square means the error is 1. Here the error is almost 0. Error is 1. Error is 0. Error is almost 1. But it's not showing that much difference. It's not showing that much difference, error difference. But if you know, just I applied mean square error. If we applied 1 minus y predicted whole square, if we applied that, very small differences it will show. Though it is a wrong class, it is predicted. Here it is predicted a wrong class. Actual class is 0, predicted as almost 1. Wrong class predicted, but the output, but the error, if we calculate with minus yp whole square, then we'll get the error as 1. Here also error as 1. Here the error is 0. Here the error is 0. So that's why the mean square error or mean absolute error or root mean square error or R square error will not be suitable for the classification problems. So here we are calculating log error. That log error will get here like this. So you can substitute here. This is our y value. This is our y predicted value. Now if we substitute, the log difference is equal to minus y into log of y predicted minus 1 minus y into log of 1 minus y predicted. If we substitute in place of y, in place of y, 1 value, and in place of y predicted, if we substitute 0.999, and in place of y, if we substitute 1, it will become 0. So only log of y predicted value is this one. And after that, here y value is 0 and y predicted is this one. Y predicted is 0.999 and 74. So here y value is 0 means this term will be cancelled, and 1 minus 0 log of 1 minus y predicted value. So here 5.585 will get. Here we can easily observe when y value is 1, when y value is 1 and the predicted value is almost 1, it is showing almost 0 difference. Almost the difference is 0. But when y value is 0 and y predicted value is 0.999, it is showing the very big loss, very big error. There is a log difference that is showing. And when y value is 1, almost 1 value, it is showing again very less error. But here, log value is y value is 0 and y predicted value as 0.999, but it's showing the log difference, log error as very big one. So that's why for classification, we are calculating error, not a mean square error, not a mean absolute error, not a root mean square error. We'll calculate the log differences, we'll calculate. Now, our intention is to reduce this mean error. If we calculate mean of this one plus this one plus this one plus this one, if you sum all and by 4, if you do, we'll get the mean log error for iteration 1. So after that, we can change the w values. Weight updation we need to here. Initially we took 1 watt in place of beta, but we can change the w value, beta values, as that is our wish. By using gradient descent method or any optimizer, we can change the w values. Again, we need to calculate the y predicted value, like first z value, then y predicted value. Again, we need to calculate log differences. So this process will be repeated. This process will be repeated until we get minimized error or we get good accuracy. Until the error is reduced very minimal or we get good maximized accuracy. So first step is to, in logistic regression, first step is to, this is our data set, form an equation, because logistic regression follows a parametric method approach. In parametric method approach, we need to form an equation with known and unknown variables. Here known variables are x1 and x2. Unknown variables are beta naught, beta 1 and beta 2. These are unknown variables. So form an equation and take any random values. Select any random values as beta naught, beta 1, beta 2, like 1, 1, 1. As I said, randomly I have to 1, 1, 1 as beta naught, beta 1, beta 2 values. Now I calculated z value. Okay. Now here x1 and x2 are for each iteration x1, x2, x1, x2, x1 and x2 will get the z value here. This is the our z value. This is not a y predicted value. We are using a sigmoid equation in logistic regression, 1 by 1 plus e power minus z, that we are using to get the y predicted values or y bar, that y values we have taken. So after taking the predicted values and we have already the actual values, now find the error between actual values to predicted values. For finding the error or for calculating the error, we are using log differences. Log differences we are using to calculate the error. So to calculate the error, we are using log differences. That equations here, we have written that same equation. This will be treated as y predicted. 1 minus y into this will be treated as 1 minus y predicted. Same equation here. 1 by m is number of rows for calculating the mean. So finally we'll get log error and we'll calculate the mean error. That mean error will be the final error for that iteration. When we took beta values are 1, 1, 1, that is the main error. Our target is to change the beta values until we get less error. That is the best fit equation. Change the beta values or change the w values until you get less error. That is the final best fit equation for the given data. In logistic regression, we need to provide an equation like y is equal to 2x plus 3. This type of equation we need to provide. Now the new user will give us the x values. Now we'll give the y values. That is the main intention of this linear regression or logistic regression or support vector machine. These three are following a parametric method approach. In parametric method, we need to form an equation. And find the unknown variables. Like here 2 and here is a 3 or unknown variables or unknown values. That is beta naught and beta 1 values here. Understood? This is the logistic regression model. Any doubts you can ask in this? You can ask any doubts in this. No doubts? If no doubts are there, then we'll see how we can update the weights for the next iteration. Here, after calculating the error, for example, here we got, we'll get the mean error as 3 point something, will get mean error. So still, if you want to reduce this error, we need to change the weights. Here, W values are 1, 1, 1. This will be updated for the next iteration, next epoch. Like W naught, this is a common method, W naught or W new value is equal to W old value plus the learning rate into partial derivation of loss function or error function. So here the loss function is this one. This one is the loss function. We need to substitute that loss function. So finally it will become, this loss will be minus y is common into log, because here we are doing, our target is to find the W values. W new value we need to find out through W old value plus learning rate will that is a constant value, and do the partial derivation with respect to W values. Here look at partial derivation we are doing on a loss function. That loss function is y into minus y into log of y predicted minus minus 1 minus y into log of 1 minus y predicted. So this loss function I have written, where we got this minus and minus. This minus is step into the equation. Now and again, here we are doing loss function with respect to the partial derivation with respect to W. But here we don't have any W values. So that's why just substitute minus y into log of, what is yp is, here we'll get yp is equal to 1 by 1 plus e power minus z, like that. 1 by 1 plus e power minus z minus 1 minus y into log of 1 by 1 plus e power minus z. This is what. Now here also the loss function is partial derived with W values only. In this equation also we don't have W values. The equation all is converted into y and z terms. Now we can't convert the y values, but we can convert z values. Z is equal to, we know that W naught plus W1 x1. This equation will be substituted in this. Now here y into minus y into log of 1 by 1 plus e power minus W naught plus W1 x1 minus same 1 minus log of 1 minus 1 by 1 plus e power minus of that's a w value w naught plus w1 x1, that is. So now we can easily do the partial derivation with respect to w. So whatever the equation we got, that will substitute here, and then we'll get the w new values for the next iteration. Here w old values means we can take as 1. Okay, and row value, it is a learning rate, we can constantly take a constant value like 0.001, neither a big value nor very small value. The medium values will take for the learning rate, then we'll can update the weights, and it will keep on going until optimal error we got, means where we can't further reduce it, error is can't be reducible, so there will stop this procedure. Until then we keep on changing the w values or beta values, and we'll calculate the error and compare with the previous error, and keep on changing until we get the less error. Where we got the less error means for which w values or for which beta values we got the less error, that beta values are fixed for the equation. That is a logistic regression model. I hope you understood. Next, we'll move on to the k nearest neighbor. So any doubts meanwhile you can ask. Okay. I will take the next model, k nearest neighbors. It is a non-parametric method. It is a non-parametric method, means no need to form an equation. No need to form an equation. In previous model, we formed an equation like z is equal to w naught plus w1 x1. No, here we are not stopping, not finding or forming an equation. Here the because it is a non-parametric method, no need to form any equation, but it can do both regression and classification model. Data regression it can do, classification it can do, and it comes under supervised learning because there is a target variable or labeled data is present. So it can do, comes under supervised learning, and it can do both regression and classification problem. Here k nearest neighbor algorithm will find out the nearest neighbors, the closest neighbors. So how many closest neighbors, that is depends on the k value. If k value is 3, we'll find out 3 nearest neighbors. If k value is 3, we'll find out 3 nearest neighbors, and their output will be the final y predictor value. Their output will be the final output value. For example, this is a data point. Yeah, this is a data point in a certain distance. What are the nearest neighbors? What are the nearest neighbors? Here, these three are the nearest neighbors. So we can take more also. That will be depends on the k value. If k value 3, we should take only 3 nearest neighbors. If k value is 4, we should take 4 nearest neighbors. Okay. If k value is 5, we should take 5 nearest neighbors. That is the parameter in k nearest neighbor. Okay, deciding the k value is the best thing in actual thing in k nearest neighbors. And previously logistic regression, we formed an equation like z is equal to w naught plus w1 x1. So here finding the optimal w value is the target. Understood. In this k nearest neighbors, finding the best k value for the given data set, that is a big task here. So here we need to find out k value, suitable k value for the given data set. If k is equal to 3, for example, let's say k is equal to 3. So this is the data point. So 3 nearest neighbors will select. For example, the y value of this one is 10. Y value of this one is 20, and y value of this one is 30. So what is the y value of this one? Question mark. So what will be if k is equal to 3 now? We found 3 nearest neighbors and their output values are 10, 20 and 30. So So it is a regression problem. So we are going to take average of their y values as a new data point value. So here the actual value is, y value is 20. Understood. In this way, we are going to find out the uh, and we are going to predict the new values. This way, we are going to predict the new values. If it is a regression problem, we are going to take the selected values average. If it is a classification problem, if it is classification, same. This is the data point. Which class it belongs to, which class it belongs to. This is one data point. This belongs to class 1. This is one more data point belongs to class 0, and one more data point belongs to class 1. If we apply here k is equal to 3, 3 nearest neighbors will find out. Okay, their y values are 1, 0, 1. So majority is 1, so that the new value of new point output value is 1. In this way, we are going to find out the output value for the new data, or we are going to predict the output. If it is a regression, we'll take the average. If it is a classification, we'll take the majority class value that will be treated as a new y value. So k nearest neighbors, non-parametric method, not forming any equation. Here, the target is to find out the best suitable k value for the given data set. Best k value. Here I said randomly k value is 3. Why k value is 3? Why not 4? That is a question mark. That is a question mark here. So that is the training process in this. So learning or training process in k nearest neighbor is to find out the best k value for the given data set. Understood? K nearest neighbors can do both regression and classification. It is a supervised learning model. Okay, here finding the best k value is our target. If it is a regression problem, we'll take the average. If it is a classification problem, we'll take the majority class as the final class of the given output. Just look at this GIF file. We can easily understood how k nearest neighbor will work. There are red class and green class data points are there. Now one new data point that is in black color, that is a new data point. So here we are calculating the distance first to new data point to all the data points. From black point to all the data points, we are calculating the distance. After calculating all the distances, we are selecting nearest to neighbors, which are near to the that black point. How many nearest neighbors? We selected, randomly selected k value as 5. So 5 nearest neighbors we have selected. After selecting the nearest neighbors, now it is a classification. Either black point is belongs to green or red. So here within the circle, in the 5 nearest neighbor, green is greater than red. So that black point is belongs to green color. Once again, it clearly observe it, which class that black point belongs to, which class that black point belongs to, or green or red. So for that, k value is 5. Why k value is 5 will answer later. As of now, take k value as 5. So we need to select 5 nearest neighbors. For that, we are calculating distance to each and every point in the data set. To calculate the distance in between new data point to each and every data point, after calculating all the distances and find out the nearest to neighbors. Nearest neighbors means the data points which are which are in less distance, maintaining less distance. That data points are nearest to neighbors. After finding the nearest neighbors, then find out their y value, their target class, which class they are belongs to. Here, out of 5 nearest neighbors, 3 points are belongs to green class, 2 points are belongs to red class. 2 points are belongs to red, 3 are belongs to green class. Now the green is majority, so green has the majority than red, so that new data point is belongs to green color. So this is a procedure of, this is the approach of k nearest neighbor. Here it is a classification model we did. If it is a regression, after selecting the 5 nearest neighbors or after selecting the nearest neighbors, we took average of their y values, average of their target values. That will be the value of new data point in regression case. In regression case, classification, majority, regression will take average value as a y predicted value. So here, this is again same procedure of k nearest neighbors. This is one class and this is another class. So which class it is belongs to? For that, what we are doing? Initially select k value, which k value is suitable. For example, take k is equal to 3 and find out the 3 nearest neighbors. Like, this is not, just assume these 3 nearest neighbors within this distance. Within this distance, the 3 nearest neighbors are, one is green, 2 are yellow, so that belongs to yellow class. In that case, same. So here, this is a common procedure in k nearest neighbors. So now our target is to find out the best k value, which k value is suitable. K value may be 3 or 4 or 2 or 1, 2, 3, 4, 5, 6, 7, 8. Any value is possible. But for the given data set, what is the best K value? Here, learning or training process. Training means finding the K value. In linear regression, logistic regression, support vector machine, learning or training means finding the best weights. Finding the best weights to provide a best fit equation. In decision tree, optimal tree we need to provide. Optimal tree, not a lengthy tree, highest tree. Optimal tree we need to provide, that is a training process. In k nearest neighbors, we need to find the best k value, best suitable k value for the given data set. That is a target variable. So how we'll calculate the distances? Here, for example, points x coordinate and y coordinate, x coordinate and y coordinate. Here we can calculate the distance between these 2 points as with by using Euclidean distance. That is equation wise, x2 minus x coordinate minus another point x coordinate, y coordinate minus another point y coordinate. So this equation we are using to find out the distance between the 2 points. Other than this, we can also use Manhattan distance, that is uh, x2 minus x1 plus y2 minus y1 mod. Now, this is a Manhattan distance. This we can use, no problem. So here either we can use Euclidean distance or Manhattan distance to calculate the distance between 2 points. To calculate the distance between 2 points, either we can use Euclidean or we can use Manhattan distance, because we can observe one common point in these two is both will eliminate a negative answer. Here also x2 minus x1 whole square, y2 minus y1 whole square. After that we are doing under root, means we never get, there is no chance, there is a no chance to get negative values here. And here also x2 minus x1 mod plus y2 minus y1 mod. So here also no chance to get negative values. To eliminate the negative values, we are following this. In that, why? Because for example, from this point to this point, the distance is 3 centimeters. Okay, and again one more point is there, one more point is there. Here the distance is also 3 centimeters. We don't want which coordinate it belongs to, whether it is positive 3 centimeters or negative distance. We don't want these. That's why we are eliminating negative sign. For that, we are calculating the distance between uh, one point to another point, either by using Euclidean distance or by using Manhattan distance. This is the distance calculation equation. Now, here we can clearly observe, just here, what is the importance of k value, why we need to select k value. Like if k value is if we select the k value randomly, any number, then what going to be happen? Just for that, just look at this example here. uh, 1 2 3 4 5 6 7 stars are there, 7 stars. 8 triangles are there. 8 triangles are there. Now the question is, this object is belongs to either stars or rectangle. Now, if we select randomly k is equal to 3, now the answer is the question mark belongs to triangles. Otherwise, if we choose k value as 7, the 7 nearest neighbors are this one. So in this, the majority is star. So yellow color object belongs to star class. To eliminate this ambiguity, k is equal to 3 is suitable or k is equal to 7 is correct, k is equal to 5 is correct or 7 is correct or 3 is correct, which k value is correct. So for that, our target in this k nearest neighbors, we need to select the k value. We need to select the k value. For which k value? For which k value will get less error? For which k value will get less error or highest accuracy? If it is a classification, highest accuracy. For which k value will get highest accuracy or less error, that k value is the best k value for the given data set. We are trying so many k values. There is no direct equation to get the best k value. So we are trying all the k values, out of which k value we are trying 1, 2, 3, 4, 5, 6. All the k values, many k values up to infinity. We are trying all the k values. But which k value is providing less error or highest accuracy? In terms of regression, less error. In terms of classification, highest accuracy. So which k value provides the this data, this values, that k value is fixed. As I said, we can use distance. We can calculate the distance by using Euclidean distance or by using Manhattan distance. Now, if you look at the one example, ID will be dropped from the data set. So now x1 we can take as this one, x2 is age and weight. Based on a height and age, we need to predict the weight of a person. Height column is there, age column is there, that will be x1 and x2, other weight will be y. So here all the values are continuous values, so it is a regression problem. Now we can solve this with the k nearest neighbors regression. Here we have tried, when we have tried different k values, k is equal to 1, 2, 3, 4, 5, 6, like that. If you have taken all the k values, for which k value we'll get less error, that k value will we are going to fix. That is a target. And here again the class, I will show the example uh, problem, example problem. Here two classes are there, x1, x2, brightness, saturation. Based on these two features, which color glass it belongs to, either red class or blue class. So it is a purely classification problem. Two features, x1, x2, and class is red or blue. Binary classification problem. And before that, this problem is regression, and this one is classification. Now we'll solve one example. Yeah, just yesterday's exam I have given this question. Is it visible to you first?
Yes, sir.
Yes, sir. Yes, sir.
Yes. Just you look at the question. It is a classification problem. Here x1, x2, x3 are the features. Target is 1, 0, 1, 1, 0, 1, 1. Here. Now question is, consider the above data as a trained data and find the accuracy. Because it is a classification problem, I asked you to find out the accuracy when k is equal to 3. Why k is equal to 3? We can take for that k is equal to 3. What is the accuracy? I asked them to calculate. Okay, and this we are using test data. But this is a test data. This is a trained data. Here, train data means given data set, we are splitting. The model automatically split the data into two parts. Two parts. One is for training, one is for testing. By using a test data, we are going to calculate the accuracy. For which k value the accuracy is good, for which k value the accuracy error is low, that k value we are fixing. So now we here will try k is equal to 3. Here we can try the possible k values for this data set. The possible k values are 1, 2, 3, 4, 5, 6. We can try almost up to 6 k values because the number of rows we can find the nearest neighbors only 6. Only 6 samples are there, so we can find only 6 neighbors. Understood? So 6 neighbors we can find out. So possible k values for this data set is 1, 2, 3, 4, 5, 6. So out of k values are 1, 2, 3, 4, 5, 6. Which k value is providing good accuracy, best accuracy, that k value we are going to fix. Or which k values provide the less error, that k value we are going to fix. That is here training means finding the best k value in. So for that, we are calculating the distances. Yeah, this is the actual data. Now this is the actual data. Let me color it as blue. Actual data. Now I'm calculating the distances from where to where. This is my x1, x2, x3 for this, from this point to the given test data. This is our test data. So understood. 2.1, 4.7, 3 coordinate data. It is x, y, z columns. Okay. Now here 2.1, 4.7, 1, 2, all the data points. All the data points. This one. These all the data points to this single data point to test data. In test data, 1 point I have taken. Train data, all the data points. 2.1, 4.7, 1, 2. Distance to be calculated to all the points. So here 6 points are there, so we'll get 6 distances. 6 distances we'll get. So that 6 distances I have calculated. 6 distances I have calculated. And no, these two, target and y, both are same. I have written as y here. Okay. So after finding the 6 distances, from where? From this point. From this test data. From this test data, I have calculated. So now next job is to, for this data point, 2.1, 4.71, for this data point, what are the nearest neighbors? How many? 3 nearest neighbors. What are the nearest neighbors? Nearest neighbors means the distance will be low. If the distance is high, far away. If the distance is low, nearest neighbors. So for this point to these all, what are the nearest neighbors? What are the 3 nearest neighbors? What are the 3 nearest neighbors? In this case, just observe the distances. For which data point the distance is low, that data point is nearest neighbors. In this case, 0.2236. Yes, it is maintaining the first distance. Next, one nearest neighbor it is, and second is, we can take this one as second nearest neighbor, and the third nearest neighbor is this one. Hence, these 2 points, this point and this point and this point, are the 3 nearest neighbors I have separated here. 3 nearest neighbors I have separated here. So after finding the nearest neighbors, now after finding the nearest neighbors, their target value, their y values we have taken. First one, y value is 0, 1 and 1. So the target values we have taken. It is a classification problem. It is a classification problem. So it is a classification problem. So majority class is the actual, majority class is the y predicted class. Now here the majority is 1. So only 1 0 is there, 2 1s. So majority class is 1. So yeah, for this data point, actual value is 0 and predicted value is 1. Again, look at here. 2.1, 4.7, 1. The actual target value is 0, 0. And based on k is equal to 3, the predicted target is 1. So is it a correct prediction? No. That is the final case. Now, one more test data they have given, like 3, 6, 1.6. 3, 6, 1.6, that is a test data, and the output is 1. So for this also, find out the distances to whom? To all. To all these points, we should find out the distances and select the nearest neighbors. Select the 3 nearest neighbors because k is equal to 3, and find out the target variable. Here it is. Now the second distances, same 6 distances we have calculated. This time, first one is this one, first nearest neighbor, and second nearest neighbor is this one, 1.5. So I'm arranging them in ascending order. Now this is the third nearest neighbor. Okay. Now here their output value is 0. Here this output value is 1. This output value is 1. So here again the majority class is 0, 1, 1. Out of that majority is 1. So for this data point, predicted value is 1, actual value is 1. That actual value I have given in here. This is the point. Actual value is 0. 3, 6, 1.6. Actual value is 1, and predicted values we got here 1 and 1. So for second case it is correctly predicted. For first case it is wrongly predicted. Now we can say the accuracy for k is equal to 3, the accuracy is 50%. Means one is correctly predicted, other one is wrongly predicted. So accuracy is 50%. Let's take k is equal to 5. Let's say k is equal to 5. Now same distances will be calculated same. Now k is equal to 5 means in that case we need to select the 5 nearest neighbors. 2 more points we need to select. Now for this first case, first data point, for this first data point, here are all the distances. These are all the distances. Select 2 more because k is equal to 1, 2, 3, 3 nearest neighbor we already selected. We are selecting 2 more nearest neighbor. Now this is the fourth nearest neighbor. This is the, yes, fifth nearest neighbor. This is the fifth nearest neighbor. Almost, except the last one, all are comes under 5 nearest neighbor. Now here, out of this, these are the y values. So 2 zeros, 3 ones, 3 ones, 2 zeros. Now again, y predicted value is the majority class. So y predicted is again 1. Y predicted is again 1. Wrongly predicted. For k is equal to 3, it is wrongly predicted. K is equal to 5 also wrongly predicted. Now here also, the second point, for the second point, when we took k is equal to 5, so we should select the 5 nearest neighbors. This is the fourth nearest neighbor, and this will be the fifth nearest neighbor. Again here also 1, 0, 4 ones, the majority is 1. So predicted value for the second point is also 1, where k is equal to 5. Now same output we are getting, where k is equal to 3, 50% accuracy, k is equal to 5 also. One is wrongly predicted, one is rightly predicted. So k is equal to 5 also, 50% accuracy. K is equal to 3, 50% accuracy. K is equal to 5, 50% accuracy. So after trying, we tried only 2, k is equal to 3 and k is equal to 5. So k is equal to 1, 2, 3, 4, 5, 6. After trying all the k values accuracy, which k value is providing good accuracy, that k value we are going to fix in k nearest neighbors. Okay, so if it is a regression problem, we'll go with the average of the output values. Otherwise, If it is a classification problem, we are going to like take the majority value. Majority class will be the predicted value. Understood? So in this way, we are going to select the best k value for the given data set. This is the whole data set they have provided. This is the whole data set they have provided. We have split it into two parts, training and testing. And after that, we are trying all the possible k values. Among all, what will be the best k value? What will be the best k value for that best k value? That k value is fixed for that data set. So this is called a training process. In KNN, we need to find out the k value. Hyperparameter is k. In linear regression, the parameters are W. In logistic regression, parameters are W, but we are using a link function. In SVM also, support vector machine also, the parameters are, known parameters are W values. In decision tree, we need to form a tree format for the given data set. Thus, this is a training or learning process in the respective model. So after finding the best k value, if a new person is came, so which class I am belongs to? What is your x values? So based on a k value, and we'll find out the nearest neighbors and we'll take the average or majority, will decide the class. That is the whole task in k nearest neighbors. I hope you understood this example problem. This is given in yesterday's exam, day before Friday's exam. This is my class. So you can try these examples. Take these all values and split the data into train and test and find out the accuracy for various k values and find out which k value is providing good. So that k value we can fix. I hope you understood two models. Any doubts you can ask me openly. So if you don't have any doubts, you can respond it. No doubts, yes doubts, raise anything, any response from your side.
Ramesh sir, continue, sir.
Okay, sir. Yes. So I hope you are listening well. Okay, thank you. Now we'll go with the unsupervised learning model, clustering. Is my slides are visible?
Yes, sir.
Yes, sir, visible.
Okay. So in machine learning or deep learning, it will be divided into supervised learning models and unsupervised learning models. Supervised learning, it can do regression and it can do classification. In regression, linear regression, classification, logistic regression. These are purely regression and purely classification. So except k nearest neighbors can do regression and classification. Decision tree can do regression and classification. Support vector machine can do regression and classification. So random forest also build from these any decision tree. That's why it can also do regression and classification. Now when come to the unsupervised learning, here x values and y values are present. Here only x values. Features are there, no target variable or no y values. Here y values are not there, only features are there. In supervised learning, X data, Y data will be there. So futures and target variable both are present, then we can do supervised learning models. If only X values are there, we can do unsupervised learning. So in unsupervised learning, we can do only clustering. Only clustering. This is called grouping of similar data items together. Clustering means grouping of similar data items together. Whatever the similar items. So the similar items is depends on the features we are selecting. Which feature you are selecting, based on that you can set them into a group. For example, you have a fruits. So if you observe, if you are considering a feature as color, then arrange the fruits into a groups based on a color. If you are considering a feature as weight, so based on a weight, you can distribute the fruits into different groups. So approach is here, which features you are selecting, based on that our output will be like that. Approach is correct, but output will get different because of there is no supervisor. There is no supervision. It is same like in our childhood, if our teacher said, by showing an apple, say orange, orange, orange means we'll call like that only. Apple as orange, orange as apple. The supervisor in that way will generate a pattern. In that way will connect it. X value is object, Y value is a name. So we are going to establish a relationship between this apple word to apple object. That is a learning process. Here, if there is no name for it, so whatever we are calling it as, that will be correct. So here no supervisor. Whatever the features you are selecting, that is correct. In clustering, grouping of similar data items. Group similar data, similarity features, similarity objects will be in one group. So how we can select the features? Which features we can select? You can select any feature. You can select any feature to cluster the given object. You can select any feature like color or weight or any features you can select to make them into groups. But after grouping, no object will be left. If you have 10 objects based on the color, you are going to make them into groups. Based on the color, you are going to make groups, means all 10 should belongs to any one of the cluster. All 10 should fit. If one is left, now that is not a good clustering. If one is left, that is not a good clustering. If there are 10 objects, select a best feature, so that these 10 objects will be clustered. How many clusters you want to make? For example, I want to make 3 clusters. 10 objects, 3 clusters. So if I am selecting color as a feature, 10 objects will be distributed into 3 groups, 3, 3, 3, but I'm living with only one. So this is not a best clustering. Now select another feature like weight. 10 objects weight, and arrange them in way based on a weight. Arrange the 10 objects into 3 groups so that all 10 objects are arranged in 3 groups, 4, 3, 3. So that is the best clustering. No object will be left alone. No object should be left alone. That is the best clustering. All the objects will be fitted in, any one of the cluster. That is a good clustering. Cluster grouping of similar data items. So based on that, we need to select the best features. Based on that, we need to. So if you are going with color, if you are going with weight, if you are going with height, whatever the feature you can select and make them into clusters. But the thing is, no object should be alone. Like that is a challenge. Now, so here are different types of clustering models are there. So we are going to discuss the k-means clustering model. That's partitioning methods, and density based clustering based on a density. Like so hair or anything, wherever the density material is available. So based on that, density based clustering, hierarchical clustering again, it is divided into top down clustering and bottom up clustering. Divisive based clustering or agglomerative clustering, these two are belongs to hierarchical based clustering methods, and grid based clustering. Grid, so we can arrange them into based on a grids, like mapping uh, Google Maps. For that, grid clustering is the approach. Like in the Google Maps, we need to arrange uh, on restaurants. We need to point out the restaurants as three groups. Total Warangal map, we want to arrange all the restaurants into three groups. So in that case, we are going to apply grid based clustering method. Okay, and partition based clustering method, just partition, dividing the given objects into 3 or 4 or more number of clusters. That is also here depends on the k value will decide how many clusters you want to make. If k value is 3, you are going to make 3 clusters. If k value is 5, you are going to take 5 clusters. If k value is 100, you are going to take 100 clusters. That is a partition based clustering method. That example model is k-means clustering. And density based method, based on the density. Based on the density, we are going to group them. That is the dbSCON and optics are the methods for the density based clustering. And hierarchical, this is the like a tree typed clustering method. Tree typed clustering. So like CSC is one cluster, EC is one cluster, uh, triple E is one cluster, second year CSC is one cluster, uh, third year CSC is one cluster. These two are belongs to CSC group, and CSC is belongs to BTech group. BTech is belongs to SRU group. So that like SRU is a cluster. SRU is a cluster which has all the departments, BTech, agriculture, all the department, three clusters. In that BTech cluster, again we have departments, EC cluster, triple E cluster, CSC clusters, three clusters. In that CSC cluster also, first year cluster, groups, students, first year, second year, third year, fourth year. First year also, section A, section B, section B. Like that, we are going to form cluster. This is a hierarchical clustering. If you are going from top down, first select the college, then divide them into clusters, mean top down approach. Otherwise, going from the students, first collect the student ID cards, based on that arrange them into clusters, then it is a bottom up clustering. From college to college, program, BTech, branch, section, and a student. This is a top down approach. From top level, college we are representing. So from that level, if you are dividing now, that is a top down clustering approach. If you are going with students, so 1,000 students are there. Now divide them into 1,000 students, CSC students, uh, EC students, and agriculture student. Now CSC, EC, we can form a BTech cluster. Agriculture student, agriculture cluster. Now combining BTech and agriculture, we can form a SRU cluster. Like that means bottom up approach it is. So hierarchical clustering method it is. And grid based clustering, any structure we can form. That is the best example model is string clustering approach. So today we are going to discuss k-means clustering algorithm. It's a partition based clustering. In that, here also finding the best k value. So the k value will decide how many clusters, means how many partitions you are going to do. If k value is 3, so my intention is to make them into 3 clusters. If k value is 2, so my intention is to make the given objects into 2 clusters. So the k value will decide the number of clusters. So the same definition, unlabeled data will be provided, no labeled data, unsupervised learning algorithm, and K-means clustering. It is a partition-based clustering. Yeah. Here also, same like KNN, K nearest neighbors, we are going to calculate the distances. Based on the distances, we are making them into cluster. Means to which center it is very nearest. So that center it is belongs to. That's cluster it is belongs to. For example, if one point is there, this point is there. This is cluster A, cluster B, and cluster C. So now this point is belongs to which cluster? So we can easily say, uh, just to calculate the distance or just to compare the features. What is your taste? What is your who are your friends? Like that, we can collect some features, and based on that features, so we can group them into cluster. Like for example, we have section A, section B, section C. 3 sections we have. Section A students are all are uh, intelligent students, like they have good marks and they are participating all activities, so they are good. Section B people are just average students. Section C are slow learners. Section A good, intelligent, all curriculum at least everything they are participating, they are all is good. B is average, C is uh, low, below average. Now a new student is came, new person joined into a college. Now our job is to which class, which section he belongs to, which section he will be belongs to. Like we know cluster class section A features, we know section B features, means intention. Section C, how they are behaving, what is their intelligence level. So we know that section A, section B, section C, we know that their features. Now the same features collect from the new student. So how many marks he got, what are the activities he participated, what are the other things he did. Based on that, we can compare with these 3 clusters and push them into the corresponding cluster. That is a K-means based clustering model. So this is our algorithm for our flow chart for the K-means clustering. We'll discuss this one after the break. Yeah, sir, we'll take a break and after that we'll complete the K nearest.
Yeah, okay, sir. Thank you. Participants, now you can take a break for 15 minutes. Now it's at 3 o'clock. And second session will start by 3:15. You can take a break for the 15 minutes and please join by 3:15 without any delay. And the post session, Ramesh sir will going to discuss about the K-means clustering algorithm and also implementation using the various Python libraries.